put this in your calculator. When you put in your calculator, you'll get, that's what I had first, 10.5 plus. Yeah, okay. So this is what it's going to look like. Basically, it gives you it's a limestone. So it gives you an idea of what it's supposed to look like. You're smart, you can plot all these points by yourself. So, let's basically, like, solve this. So, we have an idea that this is what it looks like. Kind of like this. It's like a booty looking thing. It doesn't look like that, but it's symmetrical. And it has y-axis symmetry. It has y-axis symmetry. I can't draw. That looks like a butt. I'm not even... Okay. It has y-axis symmetry, so, like, right there, and we're solving that part. Okay. Our max value, you can figure that out. It's going to be 7. And what it represents is, 7 the radius is like, this represents the distance of the center of the stage, like where the microphone is, this black dirty dot looking thing, to like the different parts of the audience. So like a distance from phone to audience. Okay. And so this is where it gets tricky. So like, types of symmetry y-axis. And it says, what does it represent in the scenario? So like, basically when you think about it, again, when something has symmetry, it's kind of like it surrounds all the places. And when you're thinking about the scenario of like a concert and a microphone, like when they're doing videos, you want to make sure that you don't drown out like one group from the other. So basically the y-axis symmetry or the symmetry represents is that like the ability of the microphone to like equalize the sound from different parts of the audience. Sound from okay, and then there's this. This you basically look at. You can look at your notes for this. The easiest way to do this is like to plot points. I mean, not plot the points exactly. So like the A value goes on the x-axis. The B value will go on the negative. So like when you do this, this is down here. 2, -2. And you know this is root 2. Like, wait. 4 plus 4. Oh, 2 root 2. Sorry. So, like, your magnitude is 2 root 2. And then this one you, like, calculate, is, like, basically, so you look at, like, what this is. So, when you simplify this, it's a 1 root 2 triangle. And as we know, that's a 45, 45, 90 triangle. So, like, basically, like, do your radian stuff, and you'll find that it's, 315 degrees. Same thing for this one, you just plot it, like, where it is, you use your radian stuff, everything like that. Basically, just work all of that. This, again, is in your notes, like, 7A. 7A is basically in your notes. What you do is you multiply, so you multiply the moduli and you add the arguments. So like your moduli are your magnitudes, like so the 6 and the 4. So when you do that, it'd be 24. And then when you add your arguments, like basically you can do that math, and initially it is 35 over 12. So cis 35 over 12 pi. 35 pi over 12. But then you have to express theta on an interval of 0 to 2 pi. So, like, obviously you subtract 24 pi over 12, which is basically 2 pi, and it's the same thing, 11 pi over 12. With the whole 24 cis thing. I'm just lazy to put that on there. And then this one, it depends on how your teacher wants you to do it. If she wants you to do it in polar form, basically what you do is that you divide the moduli again. So like it would be 6 divided by 4, 3 divided, so it'd be like 3 over 2, and then you subtract the arguments. So like basically you'll do this minus this. Cis. And, like, so when you do that, like, you can figure that out and everything. And then when you leave your answer in rectangular form, first, basically what you do is, like, you solve for it and you'll leave it in the A plus BI format. And that's, like, basically all that I did for this. Yeah, we didn't do, like, number 8 through 10. I'm probably going to do 9 later so I can put that on there, but other than that, I'm basically, yeah. So you can, like, send me your questions on Facebook, but I think I did pretty well. You owe me big time. It took me a while.